Hi, in this video, I'm going to talk about how to store 2D array as 1D array. So I'm going to tell you the truth about 2D array, and that has to do with the fact that how the computer memory is organized logically. So computer memory, which as we know, it stores everything, stores all of lists and program code and everything. Now, computer memory, logically, it is just a linear block of memory or storage. So it's pretty much like a 1D array. It's just a very, very big array. Okay, so so that's what it is. So it really doesn't matter that, if we write code in Python or any other language that we instantiate a 2D array or arrays with even a higher dimension. All of them, when they are put into the logical computer memory, they're really stored as 1D arrays. So how do we store 2D array as a 1D array? And the answer is not terribly complicated. So this is a 2D array, for example, right? And in order to store this 2D array in a 1D array, we just take the first row, store it here in the 1D array, take the second row and put it after the first row, and then take the third row, put it after the second row, and take the fourth row, put it after the third row, and so on and so forth. So conceptually, it is a 2D array, but the actual way that it is stored in memory is really just in one dimensional, one linear block of memory. Now, then the next question is, when we try to find an element in a 2D array, we go by the row and a column, right? Now, given a row and a column, then how do we find where it is in the actual 1D physical storage? Well, let's look at some examples. So let's say, element in row 1 and column 1, number 5. Well, number 5 is here, and that is at index 3 in the 1D array. Okay. Another example would be the row 3 and column 0, number 8. That is at index 6. Right. So here are my two examples, and then here are a few more. So what, let's say, row 3 and column 1, which index does it map to? And what about row 2 and column 0? Which index does it map to? And I hope that after going through a few of these examples, you can try to see if there's a formula that calculates the 1D index given a row and a column. So give this a try. And okay, so I hope you have had some time to think about it. And here's my answer. And that row 3 and column 1, that maps to 7, and row 2 and column 0, that maps to the index 4. So if you kind of look at all the rows and columns here and the indexes here, the index is really just the row index multiplied by the number of columns. So, or how many elements there are per row, right? This is row number, and how many elements per row plus the column, right? So this part, the multiplication, get us to the right row in the 1D array, and then the column index here get us to the right column in that row. So if you look at or want to see the general formula, then the 1D index is really, again, the row multiplied by the number of columns plus the column index itself. Now, with this understanding, we can actually write a class that use a 1D array to emulate a 2D array, or well, in this case, I'm going to say it's a matrix. It's a 2D matrix. So what this exercise is about is that we are to write a matrix class. So remember, matrix is just a 2D array. And internally, we will use just a 1D array to hold everything, or to all the values in the 2D matrix. But we're going to provide interfaces or methods that the client code can use to access the elements in the matrix by the row and the column. So if you see the dunder init method, it takes number of rows and number of columns. Okay, so I would like you to fill that out. But remember, internally in the matrix, we're going to use a 1D array to store all the entries. And then we're going to provide the get and set methods. Now the get method is going to take a parameter, the row or the row index, and then col or the column index, and it's going to return the value at that row and column. And the set method is going to, again, take the row index and take the column index and a value, and it's going to set the element or entry at that row and column to this value. And the usage of it is, let's say, in this case, we are initializing a matrix of 2 rows and 3 columns. And then we're going to set the element at row 0, column 0 to 1. And we're going to set the element at row 1 and column 2 to 10. Okay, so pause the video and try to implement this class, please. All right, so I hope you have implemented your solution, and I'm going to show you mine. And I'm going to, well, I already typed out the code here, so I'm going to just quickly go over this. So in the initializer, we are given the number of rows and number of columns. I decided to remember them because they could come in handy. Actually, one of them I'll use this. And now to this, remember we said, so we're going to use just a 1D array to store all of the entries in the matrix. So the number of entries that we're going to have is the product of number of rows times the number of columns, right? So that's how many, how big the 1D array is going to be. We're not given an initial value, so you can pick, something sensible. And usually in this case, in case like this, the default would be, sensible default would be a none, right? So we just have a matrix with the right number of entries, but we don't have any value for any of the entries. Now, to get the element or the entry at row and column, we just use our formula, right? That the that particular given a row and a column, the index that we're going to use to retrieve it in the 1D array is the row multiplied by the number of elements per row, or in this case, number of columns, plus the column index. Okay, so, and we just return it. Now for the setter, we use the same formula here, pretty much. That's how we get to an entry in a 2D array in a 1D array. And instead of just returning it, we set, or we assign the new value to that element in the 1D array. So that's really it for this 2D matrix that is internally stored as a 1D array. And so let me run that. And now, so remember, this is a 2 rows by 3 columns. So first row is this one, second row is this one. So row 0, column 0, that is the first element, right? And then row 1, that is the second row, and column 2, that is the last column, so that is 10. So it's doing the right thing right now. Now, obviously, the dunder string is just printing out the 1D array. It would have been a lot nicer if we actually return a string that looks like a 2D matrix instead of just a 1D array. As a matter of fact, why don't we do it now? Rewrite the dunder string so that when we print out the matrix, it looks like this. All right, so hopefully you have had some time to try to figure this out for yourself, and there are quite a few ways to achieve this. I'll show you one way that I would go about it. So I'm using a kind of a standard nested for loops that visits all the elements in a 2D array. And I'll start with an empty string, and at the end I'll return that string. Right over the iteration of by the nested loops, I'll add things to the string. Okay, so now I choose to iterate over using the row and column indexes. And every time I visit an element, that now that I have a row and column index, I just use a method that I've already written to get the value from that row and column, right? So I don't have to repeat this same calculation again. So this makes the code, easier, and it's very readable. And basically, I just convert that value at that row and column into a string. I put a space at the end, and when this for loop is done, it will give me a string that has that particular row, right? And then at the end of the row, I will put a new line so that there's a new line, and I go to the next row. So this looks very much like the print of the entire 2D array, but just instead of printing everything, I put everything concatenate them into a string and return that string. And that's obviously what a dunder string method should do, right? It should always return a string. So the result is basically that for this matrix here. So the 0, 0, this element is set to 1, and 1 and 2, this element is set to 10.